Zack.
Thanks. Hey, everybody. So we're going to talk to you today a little bit about Service Mesh as well, but we're going to slide through, go through that pretty fast. I think we've heard about it, a good bit about Mesh today. We're going to spend a decent bit of time talking about next generation access control, which is something that Ignasi and I are both very excited about. It's actually the origin of our of Tetrate's relationship and my own personal relationship with NIST as well. And a lot of the opportunity to do things like write SPs and similar came out originally of the collaborative research that we did together around next generation access control. So you heard from me already a little bit. I'm Zack, one of the founding engineers here at Tetrate. I was one of the original engineers on Istio at Google when we created that back in 2016. These days, I wear a bunch of different hats, help with the lead engineering here at Tetrate, help write some of these SPs, help do some of this access control research.
Yeah, and I have been working closely with NIST on the implementation of NGAC, Next Generation Access Control, and doing research on how we can just make it production ready, usable in the enterprise, in large scale environments, and so on. So, what is Next Generation Access Control? Just next is this one. So basically, when we think about access control, we mainly talk about RBAC, ABAC. We are all very familiar with that, right? So RBAC, role-based access control, is kind of the de facto standard that we have today. And it is, because many reasons, it just works. It is really simple, very easy to get started, very easy to understand, very easy to reason about the policies that you have. And it is also very easy to write the policies themselves, know that they are correct, that they will do what you expect to be doing. But when it comes to scaling it and having bigger environments, more complex policies, you start having some exceptions probably, not just all the users in the same group usually will have the same rights. You need to start having exceptions, adding new attributes that your access control systems need to take care of. The number of roles that you need to manage starts to grow exponentially, and all this manageability is not that easy anymore and not that easy to reason about. And so it's not that flexible, right? It's not as flexible as we would like. This led to systems like ABAC, attribute-based access control, to be created that provide this infinite flexibility that RBAC doesn't have, right? But that flexibility comes at a cost. These systems are more complex to reason about. They are even harder to understand, harder to create the right policy, because most of the time attributes do not carry enough semantics so you can understand the context where they are created, how they relate to each other. So they are becoming complex, right? And also evaluating policies and coming up with access decisions at runtime is something that is expensive, because evaluating these policies and all these attributes, the combinations, is harder, right? So NGAC...
Sorry, one aside real quick. So this is a little fun fact for folks in the room. We actually have the guy that created RBAC sitting here, by the way.
And the one that created NGAC as well.
And the one that created NGAC.
NGAC is a new standard that tries to overcome these limitations of ABAC and get the good things from RBAC, right? And it provides the same flexibility that it has, but with some rules and guardrails that make it understandable and something that you can reason about. One of the main reasons why NGAC is different is, we could say that it is an opinionated implementation of ABAC in the sense that it is based in the concept of modeling the state of the world in a graph, right? And overlaying access policies on top of that graph. So you can imagine an attribute-based control system where you model the attributes in a graph, the resources that you want to protect in the graph, the users or identities interacting with the system in the graph itself, and you model the relationships between them, between the objects, the attributes. So you have very rich semantics in there that help you have a global view that you can understand of your system.
And this is, this is important in differentiation from something like XACML-based ABAC and RBAC itself, which are fundamentally set theoretics. So one of the problems that you have there is that there's no notion of like causality or linkage or anything like that. A set is just a bag of things. When we have a graph instead, we actually can have some semantics, we can have some meaning for humans in the structure and the shape of that graph and how things are linked. It's another reason that policy authorship becomes a little bit easier.
It also helps you model different types of policy in the same graph, And NGAC allows to combine all of them in a single access decision so that no matter how many different types of policies you have, with one access decision, you can get a verdict instead of having to 2, 3 different systems to make different calls to get that.
Or even worse, having to yourself figure out, like, how do I overlay location and RBAC and time-based policy? And like, how do I run one policy that does all of those 3 things together? Because it's very hard to reason about. And so with NGAC, because it supports multiple classes of policy, we can split those out into separate policy documents. They're going to overlay. And the net result of the evaluation will be the intent.
And it is also as expressive as ABAC because all the attributes that you would put in an ABAC system, you can put it in the NGAC graph, but you can also express how they relate to each other, right? And these relationships and assignments will provide semantics that will help you configure how policies cascade down the hierarchy, further configure delegation, or do other cool stuff that we will see that it's hard to achieve with just plain ABAC. Another cool feature of NGAC is that you can use the exact same system to create administrative policies. So you have the policies that will govern your applications and stuff, but you can have the administrative policies themselves who can manage the policies and all that stuff in the graph itself. You have everything in the exact same place, and the exact same graph allows you to reason about absolutely everything, right? And as I said before, this delegation, just the fact that you configure everything in a graph, configure the relationships, how things and attributes relate to each other, provides some clear semantics for how to delegate, how to just do federation, and a lot of stuff, right? That is implicit just in NGAC. Right? So when it comes to policy evaluation, right? In NGAC, there's as opposed to ABAC, you have everything modeled in a graph, and you can imagine some sort of having all the resources that you want to protect represented in a graph, users and identities interacting with the system represented in the graph as well, and the way that you write policies is mostly about just creating some edges linking the 2 sides together, right, and saying this group or this set of attributes will have these permissions on this set of attributes. Right? And then the problem of having an access decision is just reduced to some sort of a graph traversal, trying to find a path that takes you from that user to that resource that you want to access, and collecting the permissions that have been assigned, right? So all the complexities about how you traverse this graph, and there are algorithms to be able to do that in linear time. It grows with the number of permissions and links that you have between the 2 DAGs, and also with the number of objects that you have, but you can do that in linear time, right? Which is not usually the case in general purpose ABAC systems.
Yeah, and like in a set theoretics formulation of ABAC, you tend to have like n log n or n squared performance on the decision-making algorithm, as opposed to linear performance here, or maybe even logarithmic since you're walking a tree and you're kind of functioning in the height of the tree. So the big thing there is that unlocks the ability to do quite a few operations online against the live system that would be cost prohibitive to do against an ABAC. And one of those is exactly the policy review capabilities.
Yeah. So all these semantics that you have encoded in the graph, the richer that is the graph, the more information that it has, the more that you can get from it and the more insights that you can get. And NGAC allows you to just extract that information from the graph for auditability and to explain what's going on. For example, you can just create a policy and try to understand the impact that policy could have, right? So you could ask questions to NGAC like, what are all the objects this user would have access to? Or, so, which is something that is very hard to answer in other types of systems like just generic ABAC or rule-based access control systems, right? What are all the objects that the user would have access to with this set of rules, right?
And even before the fact. So I want to apply this policy. What would be the resources that they could access if I did, right? And so that ability to do that before the fact audit in addition to after the fact is key for confidence in the policies that we author, that we know that they're going to be correct.
Also, with this way of making access decisions, reducing them to graph traversals, you can have a lot of information of why an access was allowed or denied, right? Just recording the path that you traverse, right, will give you very rich information. For example, you can model the organization structure in a graph, saying these users belong to this department, engineering, that belong to this branch of the company, And then you can model your resources. This is a service that is running in this cluster, that is running in this region, that belongs to this team, right? You can imagine while traversing this graph and collecting why you could access that thing. You can express it in terms like this user, because that user belongs to this team that happens to have an access policy that was created this day that affects this object that contains that other thing. So you have very, very rich information to understand why an access decision was allowed or why some access was rejected, right? Because often it's hard to tell, why did this user not have access to this resource? What am I missing? What attribute am I missing, right? With NGAC and all these rich semantics, this is much, much easier to answer and provides very, very insightful information when it comes to auditing or kind of understanding why you had a breach, right? Or what was the policy that allowed that access in a context that you can reason about that, right? Because the graph, you model your world in the graph with your semantics, with your business semantics, and just overlay the access policies on top of that. But the graph will provide you something, it's built in a language that you can understand, right? It's closer to your business.
And again, I'll just point out, that explained capability and that policy understanding that brings is one of the single biggest advantages over, traditional XHTML-based ABAC, right? If we wanted that kind of capability traditionally, we would have had to have gone and gotten some vendor product that does really sophisticated, crazy policy analysis and to be able to get that similar kind of insight. I want to point out that audit and explain are primitive capabilities of NGAC that are part of the NGAC specification. So you don't have a valid implementation of NGAC unless you can do these things.
And it is using the same algorithm that you use to make the access decision is the same way that you traverse the graph to get all these insights, right? So it's just that optimized algorithm that you can use for all these cool features.
Correct.
So the NGAC architecture is kind of quite common in the security world. So the main pieces of NGAC is first, one of the most important ones, the PEP, the policy enforcement point. You need somewhere to intercept the requests before they happen to just allow them or reject them. That's the policy enforcement point. The policy enforcement point talks to the PDP, the policy decision point. This is the component that implements the NGAC graph traversal and the algorithm to make an access decision if the identity of the authenticated principal that the PEP is asking about and the resource it's asking about has access to access the desired resource. The PIP, or the policy information point, is where you interact with the graph itself, where you maintain the graph, because this is the graph that you need to keep it up to date. Then we also have the EPP, which is the event processing point when an access happens, right? There is this component, the EPP, that can fire events to, for example, update the graph and do other stuff. For example, you may say, this is just a one-time logging, things like that, right? So you can update the graph when things happen, and the EPP does that.
One thing I'll just note real quick about the EPP, it is the only novel part of the NGAC architecture compared to the traditional ABAC architecture. So if you go and look at the traditional ABAC architecture diagram, it is exactly the same barring the EPP. So that's one of the novel features in NGAC that underpins a lot of the capabilities that it brings to bear. One thing I'll just call out is we're actually going to show you some graphs and do a demo next. So we're going to get a little bit more hands-on and make it a little more concrete in the next session. So don't worry.
And finally, well, there's the RAP, the resource access point, which is what the PEP will use to access the final resources once the request is allowed, right? So a normal request flow with just getting, the PEP will intercept the request. The PEP would make just call the PDP to validate that the request can go or not. If the request is rejected, the PEP will just drop it and reject it. And if the request is allowed, it will forward it to the resource access point. The resource will be fetched and returned to the client, right? And well,
yeah, and I'll just point out, in something like a service mesh-based system, I've already talked a little bit earlier today about the idea of Envoy as a policy enforcement point as our PEP. The resource access point is your service. Right, that is the thing that's brokering access to the data. So that in this diagram is really your application itself. And this is why in the service mesh architecture, and we'll talk about this in more next, we call Envoy the PEP and frame it in this way. So I'm going to go pretty fast through the service mesh. Once we have time for questions, and two, because this is like the third time we've seen some of the service meshy things today. So we'll move pretty fast. Like we talked before, it's a dedicated infrastructure layer for monitoring, securing, and managing the traffic of your applications. In the earlier talk that I gave today about 207A, we introduced the idea of identity-based segmentation, which is the minimal set of policy that we would like for folks to be doing to be considered zero trust at runtime. Service mesh, one of the reasons we'll talk about it today is because it can be used to implement those things. The way that the service mesh functions is by deploying what we call a sidecar proxy. This is a traditional reverse proxy, like an NGINX, like an HA proxy, or similar. But rather than deploying it in the traditional pattern, out separate from the applications, load balancing against a bunch of applications, instead we're homing them one-to-one with our application instances. And actually, even more specifically, we're putting it in the same trust domain as the application instance. So if we're running our applications on a VM, it means that the sidecar proxy is on the same VM. If we're running in Kubernetes, it means it's in the same pod. So they're in the same trust domain. That's why we call it a sidecar, because it's sitting there next to your application like a motorcycle sidecar. It intercepts all traffic in and out. This is key because it forms a reference monitor, like we talked about earlier today in Muli and I's talk as well. But it provides quite a few other capabilities as well, including, like we talked about, identity with SPIFFE and encryption. Per request policy, we can do other policy than merely service-to-service authorization. We can do things like rate limiting. We can do things like very fine-grained per-request load balancing based on features of the request. It provides service discovery and client-side load balancing, so we can get much more efficient network topologies and much more efficient communication between our applications as well. Again, security is a trade-off of security and availability, and we need to make a decision on that spectrum. Having the service mesh bring capabilities to help increase resiliency and availability makes it easier for you to move on that spectrum. And additionally, incredibly important, it provides metrics to help you close the loop. It provides those operational metrics about how much traffic is coming into and out of your application, whether it's erroring or not, and how long that application is taking. Additionally, it produces metrics about the policies that it's enforcing as well. And that data is what we can use to close the loop, whether that's a human looking at it and closing the loop, or we start to integrate with other software systems to do that. And then finally, none of these capabilities are novel or new. We've gotten them in a bunch of different ways, whether that was SDKs or frameworks or things like the Netflix OSS stack like Hystrix and Eureka and similar. There's a lot of ways to get these, but one of the novel things that the service mesh brings is central control of these capabilities with declarative configuration separate from the life cycle of the application, because that sidecar is not compiled into the application itself. So again, if we just look at these, we bring these capabilities, and importantly, we bring them consistently across the fleet with centralized control. And the other important thing to point out here is dynamism, easy to change. We want to be able to react to changes in our environment, immediately as they happen. And a piece of infrastructure like the service mesh facilitates that. We can push a policy to the control plane and see it pushed out to all of the sidecars, in that enforcing that policy, on the order of a second across our infrastructure, right? Very fast times to update, highly dynamic system that lets us be very nimble. And of course, we talked about this. We've mentioned Istio quite a few times. It's the reference implementation that's used in all of our SPs, SP 204 series, as well as 207A. And Envoy is the sidecar proxy that Istio uses as an implementation. Again, I'll call back to my earlier talk where, the whole philosophy around zero trust is really that a motivated attacker is already in your perimeter, if they really want to be. So really, it becomes an exercise of mitigating what somebody who's in the infrastructure can do. We want to bound the attack in space and in time. And the service mesh capabilities and those 5 policies that we call identity-based segmentation help us to effectively bound an attack in space with authorization policy, what's allowed to talk to what, to remove the pivot, as well as in time, because the ephemeral credentials that are used for that communication need to either be restolen by an attacker or the attack ends when the credentials expire. Again, Envoy is a universal policy enforcement point. Because it intercepts all the traffic, it can be a reference monitor. I would suggest for folks that are interested in this side of it, go check out SB 800-204B, which is about attribute-based access control on microservices using a service mesh. And of course, it's an NGAC policy enforcement point. Ignasi is going to demo that in just a few minutes, and we'll get in depth, show you some graphs, show you some real deployments, show you some real policy decisions. And then finally, this is one of the key ideas that, I alluded to earlier, and I want to come out and talk about directly, which is the idea of the service mesh as a security kernel for our modern distributed system. The idea is we want, a small auditable piece of code base that we offload the majority of our security concerns onto, that we use that we trust as the basis for everything else that we're building on top of. One of the reasons, we believe that the service mesh is really compelling is it can be that for our infrastructure. And then finally, it facilitates cross-cutting change. Because there's a central control plane that I can manage declaratively, it facilitates me making sweeping changes across the infrastructure without needing to go to every single team in the organization. With that, let's go grab questions. Great. Yeah, so how does NGAC scale to multi-cloud? We want to do policy enforcement closer to the asset itself, and do we need to customize there? So a couple different pieces to that question, and Ignasi, feel free to chime in. So one is we want to do the control close to where the application lives. The service mesh PEP, the policy enforcement point there, is located at the resource access point. There is no separation between those two components. In fact, the PEP is deployed into the same trust domain as the resource access point. So it would be challenging to get closer to the asset than this. So on that front, it is incredibly effective. Then the rest of the question is, how does this start to scale to multi-cloud? This is actually something we do and have does your example cover multi-cloud today by chance? It's multi-cluster? No. Okay.
No. We'll not cover it, but we can talk about that, yeah.
Yeah. In short, that becomes additional attributes that are in the graph, right? There are some additional operational challenges that working over multi-cloud introduces. We have some replication problems for the policies that we want to be enforced at runtime. But those were largely engineering problems. Tetrate is actively working on solving some of those, but they're not R&D questions. They're engineering questions. So far, we have been able to scale NGAC fairly effectively across relatively large organizations that are deployed in multi-cloud environments.
Yeah, and just to add something to that, in NGAC, everything is reduced to the need to represent the state of the world in the graph. If you can represent your infrastructure in your multiple clouds in the graph, you can just make access decisions using the same API, same semantics, no matter where things are running, right? You are just doing access control on top of a representation of your world in a graph, right? You really don't care if stuff is running in different clouds or not. Right. It's just more a discovery problem and having the graph properly populated.
Yeah, correct. And then NGAC itself is implemented as a set of microservices. The functional components on the slide deck, the EPP is Envoy itself. The PDP is an NGAC decision server. The policy enforcement point's a database, right? The policy input point is a database and a little service in front, right? So this is built as a microservices-oriented system. And I'll point out that we do those 5 policy checks that we say you should do for Zero Trust. The NGAC system in our implementation does. right? So it's enforcing access around its own components and how they communicate, in addition to then being able to do the same for your own services. And again, that's like a really important capability. We don't need two systems to manage our access. We can manage the system itself and all of the access in one go. How do you safely test policy changes? Using those audit and explain capabilities is the primary way that we see that done. That's why explain exists. Oh, perfect. And with that, I think we're out of time. Cool. Alrighty. Thank you all.